We already learned in section 4.3, which is finding an increasing and decreasing using first derivative test. On section 4.4, we're going to find the function concave up or down by using second derivative test. You're going to do the same steps, but you're going to use the second derivative test. So here's the theorem. If f is a function whose second derivative exists, that means not zero. There is a second derivative. For example, you're going to find the first derivative. There is second derivative open on the open interval I. If the second derivative is greater than zero, if the second derivative is greater than zero, then the function is concave up. If the second derivative less than zero, the function is concave down. The function concave up and then concave down at a certain point. This point is called what?
Point of inflection.
Point of inflection, because they're going to ask you the point of inflection when you have concave up and concave down on the on certain points. Let's check with the example, like a simple example. So second derivative test. Here is the function. We need to find the function where in which interval is concave up and down. So that means I'm going to find the first derivative, which is 30x minus 30x squared. This is only the first derivative. Then, by using the first derivative, you can find the increasing and decreasing. Then I'm going to find the second derivative because that's my goal. So second derivative to the x is going to be equal, going to be 30 minus 6x. So if I took the second derivative and equal to 0, that's me. 30x equals 6x divided by 6. So x is going to be equal 5. That's mean at this point, I'm gonna check the left side and the right side to find the function is concave up or down. That's mean here is our line and here is 5. I'm gonna check the positive side and the negative sides by using the second derivative test. So the second derivative, 2. I'm gonna choose a point here on this side, which is you can choose 0. Can I choose 0? Yeah. And I'm gonna choose 0 here, and on this side you can choose 6. That's mean f to the 0, f double prime to the 0, which is the second derivative. It's going to be 30 minus 6 times 0. This is 0. That's mean equal 30. So it's positive. That's my goal is to care about the sign. That's mean on this side is the function as well. Concave up. Now f double prime to the 6, which is equal 30 minus 6 times 6, which is equal 30 minus 36, which is equal negative 36. I'm going to care about the sign. That's mean on this side, the function is concave down.
It's negative 36.
Oh, it's negative 6. Yeah. Again, I'm just going to care about the sign. So that's mean if I'm negative infinity to the 5 is what? Concave up. And from 5 to infinity is concave down. So we need to find the inflection points. We're going to find the first derivative. So if I find to the x is going to be equal -3 x squared plus what? 12x minus 9. Now what's the next step?
Take the second derivative.
Second derivative. F prime to the x going to be equal -6x plus 12. Now the second derivative of the 0. I'm telling you, you have to know what you're doing. Because you can have first derivative test next section and the second one. From the first derivative, you're gonna find concave up, increasing and decreasing. From the second derivative, you're gonna find what? Concave up and down. Okay? So equal to the 0, that's mean 6x equal to 12. So you're gonna divide by 2 by 6, x equal 2. That's mean, here's the line. 2, this is the negative infinity side. And here's the infinity. So I'm gonna choose 0 here, and I can choose a 3 here. Let's check the second derivative. Second derivative of x, which is equal -6x plus 12. That's mean the second derivative to the 0, -6 times 0 plus 12. This is 0, so it's going to be equal to 12. So the fraction on this side is what?
Positive.
It's going to give up. Then the second derivative of 3 is going to be -6 times the 3 plus 12, which is -18 plus 12, and then it's going to be equal. On this side, the function is what?
Downward.
And again, to find the inflection point, you're gonna plug in 2 where? Here. That's mean f to the 2 is going to be equal. You're done here. On this side, we're gonna find the inflection point. I'm gonna plug in 2 here. That means it's going to be -3 cubed plus 6 times 2. Why I put the 3? It's 2. 6 times 2 squared minus 9 times 2. So this one is -8 plus 24 minus 18 minus 7. Yes or no? So this is 26, -2, -9. That means going to equal -9. So our inflection point is what? 2, and the y is -9. This is our inflection point, where the function is concave up and then concave down. So let's check this one. It's a trick. We're not gonna do that much steps. Here's our function on interval 0, -2 pi. That means the first derivative of an x is going to be 1.
Minus.
Okay, let's say plus 3. The derivative of cosine is negative sine x. That means the first derivative of x equal 1 minus 3 sine x. This is only the first derivative. Now I need to find the second derivative. Okay. 1 is going to be 0 minus 3. What's the derivative of the sine?
Cosine.
Cosine x. That's mean the second derivative of the x is going to be -3 cosine x. Now we're going to take the second derivative equal to the 0. -3 cosine x. Wake up. Gonna make you sleepy.
Divided by -3 both sides.
Okay, that's mean if you divide by -3, it's going to be also right.
Cosine x. 0.
Cosine x is going to be 0. That means x equal 1. Which angle between 0 and 2 pi give you cosine equal 0? That's mean our point is here's the 0, and we're going to choose 2 pi. And then the point is pi over 2 and 3 pi over 2. This is 270, this is 90. Cosine 90 is 0. And cosine 270 also 0. Now what's the next step? Here's the important part. Here is the important part. How much the angle here?
At 90.
90, okay? How are you gonna find if it's 90? Pi is 180. 180 divided by 2. If you want to work with the degree mode, you're gonna type it pi over 2, but 180 divided by 2 is going to be 90. Now I need an angle less than 90.
That's 45.
45, which is pi over. So here's pi over 4. Here's my first test point. Now, between pi over 2 and 3 pi over 2. Pi, because between pi over 2 and pi, 3 pi over 2, you can choose pi. Between 3 pi over 2 and 2 pi.
Five pi over 6.
No, that's too much. 5 pi over, which is 5 times 180 divided by 3 is going to be 300, which is less than 2 pi, which is the 360. So here is my next one. Now, the second derivative of pi over 4 is going to be equal. You're going to plug in pi over 4 where? Here. So it's going to be -3 cosine pi over 4. Cosine pi over 4 is
45.
cosine, I'm saying, not that. 1 over square root of 2, negative or positive? Positive, because all the angles is positive. And we have -3, so it's going to be -3 over square root of 2, which is negative number. Right? What's that mean? This one is concave.
Downward.
The next one, f double prime to the pi equal -3 cosine pi. Cosine pi. Cosine pi is -1. Yes or no? -3 times -1. 3, that's mean this one is concave. Now f double prime to the 5 pi over 3. It's going to be equal. -3 cosine 5 pi over 3, which is equal 1. Cosine 5 pi over 3, that's mean cosine 60.
So when you times it by -3 would be a negative.
Which one? How much cosine 60?
Oh, I typed cosine 5 pi over 3 and I got the decimal.
Doesn't matter. Decimal with the negative, that means going to be negative. Which is -1 times -3. How much going to be? Just
Negative,
multiply the result. Yeah.
it's a negative,
It's a negative what?
negative 0.996.
996. Did you multiply it by negative
I
3? Okay. It doesn't matter. This is the negative sign. So, because we're doing a test, that's mean this one is concave. So. Because sometimes that's what we're gonna find. Inflection point, but when we graph it, we're not gonna care about inflection points. But we already, if we need to find the coordinate, we know this is the inflection points because it's a point. We can locate the point on the graph. So we're gonna put the point on the graph, and I know this is inflection point because is what? This side can give up, and this side can give down. And here's another point. This side is gonna give down, this side is gonna give up, okay? So that's our goal. Now tell me, what's the first derivative? Yeah, we were waiting for you. How are we gonna solve this one?
Same thing, first derivative,
How? Tell me.
that'll be 3 plus. Come on, guys.
Oh,
The quotient rule, right?
What?
The quotient rule? Yeah.
The quotient rule. Think about that. Okay, you're gonna use the quotient rule here,
Cosine.
which is okay. I'm not gonna say it's wrong, it's another way. Can we solve it in a different way? Where's the problem with this example? You wanna use the quotient rule? Go ahead, use it. But always,
What are you doing?
too snarky.
always look for the easiest way, right?
Okay.
Okay, so before, so go ahead, you can use the quotient rule, and you're gonna keep going, it's gonna be really long steps. So,
You're gonna show us any trick?
of course, that's our goal. So now, think about this part here. 7, keep the 7 on the side. 1 on the side, x as well.
That is.
So here is 3x plus 7 cosecant x. You see, this is easier to work on it. I'm not gonna care about the quotient rule. Now I need just to work on the derivative for this part. That's means the first derivative of x equal 3 plus 7. What's the derivative of cosecant?
Negative cosecant x times
Negative cosecant x cotangent x. Okay. Check what's gonna happen. Now I'm just gonna rewrite this one again. So it's going to be 3 minus 7 cosecant x cotangent x. Yes or no? The second derivative of the x equal what? This is 0. Now let's look here. It's a product, right?
7.
So -7, the first one times the derivative of cotangent is what? What's the derivative of cotangent?
negative cosecant x squared.
Negative cosecant square x plus, keep the negative out. The first one times the derivative here plus the second one times the derivative here, which is
Is the 7 cosecant x cotangent x?
cosecant x. No,
No,
what's the,
wasn't that what we said?
Wait.
It was?
here is the negative out, don't worry about the negative. The first one times the derivative of the cotangent, right?
Mhm.
Plus the second one should be this.
Yeah.
The second one is going to be cotangent x times the derivative of cosecant as well.
It'll be without the 7, right?
Don't worry about this side. Or this one.
Okay.
What's the derivative of cosecant here?
You said it was cosecant, negative cosecant x cotangent.
Cosecant x, cotangent x. And this is close, this is the point. Second derivative of the x equal what? Here is going to be what? Careful, multiply these is going to be negative, with the negative,
Positive.
positive, so 7 cosecant cubed to the x. And I have negative here, with the negative here is also positive. Cotangent with the cotangent, so 7 cotangent square x, and here's the second derivative. Let's see what else. Put the second derivative equal to 0? Yes or no?
Yes.
Why I put 2 x's here?
About to ask you that.
So tell me,
I just noticed it.
it's error x. X cosecant x equal 0. Now who's gonna tell me how we gonna solve this beautiful? Wow.
Factor.
Whatever you want between -5 and 0, and whatever you want between 0 and 5. So the plug and pi over 2 is going to be positive. That means this is positive upward. So from -pi to 0 is downward, concave down. From 0 to pi is concave up. And again, be careful. It doesn't mean this is downward, the second one is going to be upward. Okay? If the function is keep decreasing, that means you're gonna get downward, downward. What about if it's increasing? Sometimes it's going to be upward, upward, and keep going like this. The function like this. Okay? They're gonna say, okay. The first derivative of the x is going to be the x squared minus 1 times the derivative of the top is 2x minus x squared plus 1 times the derivative of the bottom is so x, and everything divided by x squared minus 1 squared. Next step, you don't have, you're not gonna find the second derivative right away. You have to simplify the first one. How are we gonna simplify this one? 2x cubed minus 2x,
Is it gonna be 0?
wait, minus 2x cubed minus 2x. What?
Minus? No, it should be.
Are we supposed to distribute the negative sign?
That's what I did.
Oh, yeah.
I distribute the negative sign,
Yeah.
and I distribute the 2x over x squared minus 1 squared. And then this is 0, so it'll be negative 4x over x squared minus 1 squared. Long steps. Second derivative is going to be the bottom part times the derivative of the top is -4 minus the top part times the derivative of the bottom part, which is what? 2, the chain rule, x squared minus 1 times what? Times 2x. Here's going to be. This one cancel, this one cancel. Oh, yeah, that's. Okay. This is a plus 16x squared. And then here's plus 16x squared. There's 16x squared. And there's going to be negative 4x squared plus 4 plus 16x squared equal 0. Now we can combine these together. Still have something wrong? Yes or no? I'm gonna get it. Combine the lactase here. That's gonna be what? 12x squared plus 4 equal 0. Yes or no? Now 12x squared is going to be equal what? Negative 4. Divide both sides by negative 4 by 12. Going to be negative 1/3. Yes or no? The whole work for nothing. I get mad. Because x is going to be what? Plus or minus square root of what? 1/3. 1/3 what? 1/3 what?
I, 1/3 I.
Imaginary number?
Yes, because we have negative number. Taking square for both sides. All the work for nothing. Now what I'm gonna do? What I'm gonna do? Who's gonna tell me what I'm gonna do? What I'm gonna do, I'm just gonna go, okay, what I'm gonna do, write down the function again. X squared plus 1. So about x squared minus 1. I'm telling you, what I'm telling you, all the work is for nothing. Okay? So I wrote this one again. But I still have the second derivative, which is, here's my second derivative. What I'm gonna do?
You don't feel like that's wrong?
Now, no.
No.
Even if there's something wrong, you're gonna check it. I'm not gonna check it. But I have complex number here.
First derivative, we got that.
Yeah, I have a critical numbers here. Sorry, complex number. So I'm gonna go back to the main function, write it down again. What I have to do, I still have second derivative. So my solution is right, but I can't find the number because my critical numbers here is what? Complex. So I'm just gonna ignore it. This is not my major. This is different topic. It's a complex field, okay? So it doesn't mean it's wrong. It's a complex field. So they're gonna drive it, like find the solution, not you, because your goal now is to find how I'm gonna find the concave up and down. Where's the problem?
0,
What does that mean? Not 0.
positive 1.
1. 1,
1 and what?
negative 1,
Which is what?
which makes it equal to 0 in the denominator, which makes it undefined.
Okay. What does that mean?
As an asymptote.
So your x is 1?
No,
Is that
no.
what you're trying to get to?
Which number I gonna put in here to make the function undefined? She said 1 and positive 1. What's that mean? I always telling you that. Don't forget that. And you keep
Wait,
forgetting.
those are the asymptotes?
The vertical asymptotes? Oh.
It's a rational. So keep in your mind, when it's a rational, you have an asymptote. How are you gonna find the asymptotes? Just check the bottom part, equal to the 0, solve it. X squared equal 1, that means x equal what? I have two asymptotes, so the function is not defined as -1 and 1. Now I'm gonna check where's concave up and down by using the asymptotes. So here I can choose -2, 0, and 2. Now tell me, plug in these numbers here. With the second derivative, if we plug in -2, -2 squared, 4 minus 1 times -3, -4. So on the top, we get -12. Then I say, okay, here's -12.
Is that a plus or a minus
What do you mean?
up there? Cause it's plus 16 x squared, is that?
We didn't
plus?
finish.
Oh,
So here's
okay.
-2 squared, 4 times 16, 64. That could be plus 64. So on the top is going to be positive number. Now on the bottom here, -2 squared is what? 4 minus 1, 3. 3 cubed, 27. Now positive divided by positive is what? That means so the -2 is going to be positive number. So this one is concave up. You know what I'm doing? Or you lost?
I don't think what you're doing.
Now plug in -0. Add the prime to the 0. Equal what? Plug in 0 here, so it's going to be -1. -4 times -1. So here's 4. Plus 0 over. Plug in 0 here, so -1 cubed. So what's the result? That means this one is concave down. Can you do the same thing with the last one? See, don't overthink it when you plug in the numbers. Plug in 2 here. 2 squared 4 minus 1. 3 times -4. -12. So here is -12. The same thing here. 16 times 4 is going to be 64. So this one is positive.
Same thing, yeah.
The same thing. So that means f double prime to the 2 is going to be also a positive number. That means here is going to be what? Don't give what? Don't give up.
I don't like this question.
Good. How are we gonna solve this one? Find the first derivative, which is combined to the x of. I'm gonna find the first derivative. Maybe I do. No, don't do that. Make it easier. If you use the product rule, you're gonna say the first one times the derivative of the second one plus the second one times the derivative of the first one is going to be 0. So keep it just outside. Because if you distribute it, it's going to you get the fractions, right? So now don't work with the fractions. The first one times the derivative here times what's the derivative here? -15x4 plus what? 120x squared plus 140. Yes or no? Plus the second one times the derivative of the first one is going to be 0. Now what's the next step? The second derivative is going to be 1/270. And what else here? Negative what? 60 x to the cubed plus 240 x. Now I'm gonna put the second derivative equal to 0. Can I factor out now 1 over 270 negative 60x cubed plus 240x equals 0? Yes or no? Factor out negative 60 as a common. What's the left? What's the left here?
Well, you can do negative 60x.
You can take negative 60x, yes. So it's going to be squared plus what? 240. Factor out the 60 is going to be 4. I'm going to be minus here. Cancel this one with this one. So it's going to be over 9x and x squared minus 4 equals 0. You don't know. So it took us 2 over 9. X, and here is x minus 2, x plus 2 equals 0. That's mean x is going to be 0. Got it? Put down the line. Negative 2, 0, and 2. And you're gonna check.